the different families comes under SDN. And then we will compare traditional WAN and SD-WAN. Then we will compare underlay and overlay, and we will compare also like how underlay and overlay used to work in traditional WAN and how these two things are working in Cisco Catalyst SD-WAN. Later, we will move to SD-WAN components. We will learn all the control components like vManage, vWAN, and vSmart. Then we will learn what are the protocols which are very useful in SD-WAN. The main control plane which take care of it is like OMP protocol. So we will learn about OMP protocol. Then we will learn about there are various OMP terminology like system IP and all. So we will learn all the terminology which we will use in the SD-WAN fabric. And at the later stage, we will learn how we can deploy these SD-WAN deployments, and we will also learn about certificates which are used in SD-WAN. Okay, so let's start with MPLS. Okay, so before jumping in MPLS also, I would like to discuss some point like I want to discuss. So let's think about that traditional routing, how traditional routing used to work. Okay, traditional routing. So we used to see in traditional routing what happens if any router receives a packet, then how router used to take decisions and how router will be used to forward that particular packet out of that interface. So we used to know that we have routing table. Later we got to know about the RIV and FIV. So in traditional routing, we had three types of concept. At first, we used to use process switching. So in process switching, what router used to do, whenever router used to receive any kind of packet, whenever router used to receive any packet in its interface, it will take decision based on its routing table, and then it will. So whenever router take decision on the basis of routing table, it means control plane is being involved. So that is called process switching, and process switching used to take a lot of time because router usually receives so many types of packet and so many number of packets at a same number of time. So if any router used to use routing table to take the decision to forward the packet, so that will used to take so many times. So the efficiency of the router will be very worst in that condition. So Cisco has come with the we come with the solution of, after process switching, we used to come with the solution of fast switching. So in fast switching, we came with the concept to increase the efficiency of this particular router. We have thought that instead of using the routing table, the routing information base, the FIB is also used to maintain by the router in order to do the switching fast. In fast switching, they have a pre-constructed layer 2 header as well, so that and in FIB they used to have information of exit interface also, so that at the time of the packet is received on this interface, the router will forward immediately onto this interface. But the drawback of this fast switching also, that in first whenever router receive any first packet, then it will have to go to the routing table, but for second and for later packet, then the forwarding will take place on the basis of FIB. So uh, time evolved, new technology come. We came with the concept of SAF, which we called as Cisco Express Forwarding. So in SAF has also increased the efficiency of the router. So the switching becomes very fast with the concept of FIV, and they used to have like earlier in fast switching, for first packet it has to look up to the routing table, but in SAF it doesn't need to look to the routing table for first packet also. For all packet it can directly refer to the FIB, because FIB sit on the data plane. So we will learn control plane and data plane also later. So at first yes, for MPLS also, MPLS will work only if the SAF is working on the routers. So now we will check how uh, what in MPLS what happened, how how MPLS works. Okay, so every one of you know that every packet has a every packet at layer 3 it has a IP packet, right? IP packet, and on layer 2 it has either SDLC, or if it is a Ethernet link, then it will have MAC address detail like. Okay. So in earlier scenario, in traditional routing, router will take decision on the basis of looking at the IP packet. Router used to look at the IP packet. Router used to look at the destination IP address, and that destination on the basis of that destination IP address, router used to check its routing table, and then it will check whether it has route or not, and then it used to send to the packet to the required destination. Okay, so this is all route, right? So in MPLS, what happened? MPLS has bypassed this product. MPLS has bypassed this complete process of looking at the IP packet. In this, what happened? In between IP packet and SDLC, if we are using MPLS, okay, if we are using MPLS here, if we are using MPLS, then MPLS header will be attached between IP packet and SDLC. Like, whenever we ping from one router to another router, then the packet is hand over to ICMP protocol, then the packet is hand over to IP packet, and then usually in traditional it directly hand over to next protocol, and then IDLC or any other protocol at layer 2. It's included, and destination MAC address and source MAC address has been placed. But in MPLS, what happened? Another type of packet has been imposed between IP packet and MPLS packet, and I will tell you how this will improve the efficiency of the router. Okay, so this is a 4 byte information. This MPLS packet is a 4 byte information. I'll tell you what are the content. Okay, like in MPLS header, it is a 4 byte. The size of the MPLS header is 4 byte, and the size of the IP header is minimum 20 byte, and it can extend to more 40 byte as well. So whenever this complete packet will be sent to whenever this complete packet will be sent to the router, whenever this complete packet will be sent to any router, then router will not look up at its IP packet, because earlier it was looking at the IP packet, and the size of the IP address is 32-bit, and the size of this MPLS header is less than. Let me tell you the complete header first. Okay, MPLS header. This is the label. This is I'm telling you the MPLS header. So at first we have a label, and the size of the label is 20-bit. Okay, and then we have experimental bit, and these experimental bit are used to uh, provide the quality of service, to prioritize the traffic, and the size is 3-bit. And then we have a bottom of stack indicator, 3-bit, and then we have TTL. Okay, 8-bit. So the label, the size of the label is only 20-bit, and the size of the complete MPLS header is 32-bit. Okay, so earlier router was looking at the destination IP address, and the size of the destination IP address is 32-bit, and now the router is looking at the label, at this label field, and the size of the label field is 20-bit only. It means now router is router is only reading only 20-bit. It means the efficiency of the router has been increased, and and it will forward the all that packets with more efficiency and fastly. So this is the first benefit of MPLS. We can have like the switching is fast in MPLS. This is the first benefit. We will later understand what are the main application of MPLS. So we will later understand. Before jumping to ahead, I would like to discuss this label. Like this label is from 0 to 15. Uh, these bits are reserved. Okay, from 0 to 15, these bits are, we cannot use these labels from 0 to 15 because these are reserved. If any router wants to use labels for any prefixes, then router needs to use 16, 17, and so on. So, but router cannot use these 0 to 15. Okay. Okay. So now let's understand how these actually work. Okay. So how MPLS work, and how labels gets assigned to each other. So I'm going to draw a topology. Consider we have this R1 router, R2 router, R3 router, and R4 router. Suppose that from R1 router, we have a LAN connected like 10.1.1.0/24. And on R4, there is a LAN connected, any prefix we can give. We are giving it 40.1.1.0/24. Okay. And R1 is connected to R2. R2 is connected to R3, and R3 is connected to R4. So I'm going to tell you how MPLS work. MPLS use LDP protocol to distribute label. So I'm going to tell you how these how labels gets assigned. Okay. Yeah. So from between R1 and R2, we are using, suppose that we are using 12.1.1.0/24 network. On R2, suppose that we are using 23.1.1.0/24 network. And on R3, suppose we are using 34.1.1.0/24 network. So this is very important, which I'm going to tell now. So what I'm going to tell you, the tables will be created by each routers. Okay. So this is the table of R1. This is the table of R2. This is the table of R3. This is the table of R4. Okay. So at first in this table, I will tell you what we call this table. We call it LFIV, but I will discuss that later. At first, I'm telling you, uh, it has the router one has directly connected network of 10.1.1.0/24 network. So can I write it like this just to understand, because we have less space? Okay. So I have 10.1.1.0/24 network. It is directly connected. 12.1.1.0/24 network. 23.1.1.0/24 network. 34 network and 40 network. Okay. So now now with the help of LDP, LDP is a label distribution protocol. I will come to that point. With the help of LDP, what will happen? LDP will assign local label to each prefixes, and then after assigning local label to each prefixes, LDP will be used to send this information to all the router. Okay. So at first, what will happen? Uh, Local label will be assigned to each and every prefixes. Okay. So suppose that router 1 has assigned 11 label number 11. Like, it will not assign 11 number, because I've told you 15 0 to 15 is reserved. But for understanding, I have written this. Okay. For 12 network, it has assigned local label of 12. Local label 13 has been assigned to 23 network. Local network 14. Local level 14 has been assigned, and label number 15 has been assigned to 40 network. Okay. And suppose that like IGP protocol has been run between all the router. That's why these routes I can see in the table of R1, because IGP protocol, suppose that suppose that IGP protocol, any IGP protocol has been, whether it is OSPF, BGP, or RIP, EIGRP, any protocol. That's why we can see every prefixes. Okay. So we are now on the R2 table. R2 will also have the same. Now what will happen? R2 will also have all prefixes. R3 will also have same prefixes. And R4 will also have same prefixes. I need to delete it, because same label will not be assigned by each router. It depends, like, if it is free or not. Because it depends whether router has assigned any previous label or not. Okay, so it has started assigning 11 label to 10 prefixes. But what happen if 11 label is not free in the in routing table of R2, in LFA table of R2? Okay, that's why I'm saying local label will be different. Suppose that R2 has assigned any other label. Uh, Suppose that 21, it has assigned 22, 23, 24, and 25. And R3 on R3 router, it has assigned 31 label. For 12 network, it has assigned 32 label. For 23 network, it has assigned label number 33. For 34 network, it has assigned label number 34. For 40 network, it has assigned label number of 35. Okay. And for on R4 router has assigned, suppose that it has assigned 41 label number to 10 network, 42 network, 42 level, 43, 44, and 45. So this is the work of LDP. Okay, let me tell you LDP also. What is LDP? LDP is a label distribution protocol. Label distribution protocol is used to assign label to all prefixes and then send the information of local label to its neighbors. Earlier, we used to have TDP protocol also. Like TDP is a tag distribution protocol. It was Cisco proprietary, but LDP is a open source. So right now, everyone uses this LDP only because uh, LDP is widely accepted now. Cisco is also started using LDP. But earlier on our earlier iOS releases like 12.0 or earlier, still TDP protocol is by default running. If you want to change, then you on old platform you need to manually write. We want to use LDP only. Don't want to use that. Okay. Yeah. So this is the first functionality I have told you. Now I will tell you the first functionality of LDP protocol is to assign local label to each prefixes. Now second functionality is to use remote label. This L means local label. It will be remote label. So R1 will send this information to R2 and R2 will send this information to R1 because LDP is running between R1 and R2 and both are LDP neighbors. So once they become LDP neighbor by exchanging hello packets and once they are LDP neighbors, so they will start sending their update message. On their update message, they will share their this table information like local level. So local label of R2 will now become the remote label of R1 and the local label of L1 will now local label of R1 will now become the remote label of R2. Okay. So suppose that it has suppose that it has said this information to R1 and R1 has said this information to R2. Now what will happen? Now local label of R2 has become the remote label of R1. It means for 10 network, the label is 21. For 12 network, the remote label is 22. For 23 network, the remote label is 23. For 34 network, the remote label is 24. And for 40 network, the remote label of R1 is now 25, which is local label of R2. Okay. So it will happen to all these things. This is remote level, and R1 has shared this information with this. Okay, understand this thing. R1 has only one LDP pair. That's why it has only one remote level. Now what will happen? R2 has two LDP neighbor. One is R3 and one is R1. Okay, R2 has two LDP neighbor, R1 and R3. Now R1 will share its information, its local level of information to R2, and R3 also will share its local level information to R2. Now R2 will have two remote levels. Okay, it has received one remote level from R1 and it has received one remote level from R3. So now what will happen? It will have like 11, 12, 13, 14, 15. And R3 will also send this information. So it will have 31, 32, 33, 34, 35. Okay, local level of R3 has become the remote level of R2. Okay, so the same will happen here also. Because R3 also has two neighbors, R2 and R4. That's why in this table, uh, it will have two remote levels. So it will use R2 level. Also, one more thing. These router will never share the information of remote level. All the routers will only share the information of local level only. Okay, so the R2 will never share the information of remote level to R3. R2 will only share the information of these local level with R3. Okay, so now it has written 21, 22, 23, 24, 25. And R4 has also shared the information of local level with this. So it will write 41, 42, 43, 44, and 45. And the same thing will happen here also. R4 don't have two LDP neighbor. R4 has only one LDP neighbor, which is R3. That's why R4 will only maintain one remote table for all its prefixes. So local level of R3 will become the remote level of R4. That means for 10 network, it will assign 31, uh, 32, 33, 34 for 34 network, and 35 for 40 network. Okay, so I told you the first responsibility of LDP, which is to assign local level to all its prefixes. Now this is the second functionality of LDP of level distribution protocol, to share the information of local level to all its LDP neighbors. Okay, now understand what this level means. Okay, look on this R1 router. R1 has assigned 21 label to 10 prefixes. Okay, now and then we have seen that R1 has shared this information to R2, and then R2 had updated one entry that R1 has remote level of 11. So that means R1 is telling to R2 uh, R1 is telling to R2 that if you want to reach 10 network, if you want to reach this network, then I have assigned the label of 11 to 10 network. So just send me, so don't send me that, don't send me any packet that you want to reach 10 network. Just say that, just say that 21 level. I will understand that you want to reach 10 network, and I will send the packet to here. So this is the meaning of local level. So that's why 21 is the remote level. Oh, sorry. This 11 is a remote level for R2. So 11 is the remote level of R2. That means R2 know that if I want to reach to 10 network, then I will instead of using 10 prefixes in IP header, I will use MPLS header, and I will use MPLS label in MPLS header, and I will write 11, and I will send this information to R1, and R1 will understand that 11, the label 11 means this particular packet wants to reach to this 10 prefixes. So this is the exact meaning of these labels. So uh, this is the main thing. Okay. So uh, the two functionality we have discussed. So all these table are called as LIB table. This is LIB table. This is LIB table. This is LIB table, and this is LIB table. LIB means label information base. Okay. So you can see this is not a best table. Okay. So it will create best table also, and the best table will be called as LFIB. So we will discuss now how it will create LFIB table. Okay. And LFIB table, all routers will create LFIB table on its own by referring to the best route, and the best route they can see on the CEF. That's why we say that CEF is important if we are running MPLS, because if we are not running CEF, then MPLS will not work. And if you disable CEF from the router, then what will happen? Router will definitely create LIB table, but router will not create the LFIB table, because LFIB table is created uh, uh, on the basis of staff table, so that they can take the best path. Because you can see these are all paths, these are all routes and all paths, but LFIB table needs to be created to have the best path. So this is LFIB. Okay. See, as you can see here on router 1, as you can see on router 1, two prefixes are directly connected, which is 10 network and 12 network. So this is its best routes. Okay, because it is directly connected, and ID value is also 0. That means anybody else, what anybody else will tell the information of, because router knows everything of its connected routes, and these are best route. Okay, so these are already best routes. So this information need not to be present on the LFIB table. So on LFIB table, directly connected routes will not be added. Only indirectly connected routes will gets added. So on LFIB table of router 1, so 10 and 12 network, it is directly connected. So on LFIB table of R1, it will put the information of 23 network, 34 network, and 40 network. So let me write here. It will write 23.1.1/24, 23 network, 24 network, and 14 and also 34 network, 23 network, 34 network, and 40 network. It will also have one local level and one remote level. So local level will be used from the LIB table. So local level of 23 network is 13. Local level of 34 network is 14. Local level of 40 network is 15. So these levels are just copied from the LIB table. Okay. So now we will check remote level. So remote level, so we have only one LDP neighbor. So the remote level will also be best for this network. So for 23 network, the remote level is 23. You can check here. Okay, for 23 network, we have used the remote level of 23, and this is also best. So that's why I write 23. For 34 network, the remote level is 24, and for 40 network, the remote level is 25. So a router has updated this information with the help of best routes. Okay, that's why it has not uh, added directly connected network, because directly connected are directly connected that are 100% trustworthiness routes. Okay, so 320. Same will happen on router 2 also. The same thing will happen on router 2. Who are the directly connected routes? 12 network is directly connected to R2, and 23 network is directly connected with R2. So that's why R2 will not install these two network in its LFIB table. Rest information will be installed. So uh, it will add 10 network. 12 network is directly connected, 23 is directly connected. So it will use 34 network, and it will use 40 network. And a local level here is 10 network is 21, 34 is 24, and 40 is 25. So remote level, now it will check what is the remote best remote level. Okay, let me write it here. This is local level, and these are remote level. So for 10 prefixes, we are getting 10 prefixes from here. 10 the information 10 prefix is here. It means via R1 we are getting best route, but via R3 it is worst route. The best route is via R1. Okay, so that's why we will write 31 here, because it is the remote level we are getting, and 34 and 25. Okay, so this is the main functionality of these are the two functionalities of to create the LIB label, then create the LFIB label. Okay, now we will jump to the MPLS, like how MPLS, what is the exact MPLS topology. To understand the exact MPLS topology, suppose that we have one MPLS cloud. I'll just let you understand. This is the one. This is the ISP router. This is the service provider router. These are the service provider routers. Okay, and these are the customer edge routers. This is MPLS cloud. This is MPLS cloud. So any internal router which are present in service provider router, we call it as provider router. So this router will be called as provider router. Okay. And any router which is placed at the edge of the router, which is called as provider edge router. And this is also called as provider edge router, because these router are placed at the edge of their MPLS cloud. Okay. And suppose that we have any site uh, and any router which are connected at the edge of the customer premises, that will be called as customer edge router. And here it will be called as customer edge routers. Now MPLS will only run on the MPLS cloud only. MPLS will never run on the customer premises, because the main benefit we get to use the MPLS is on the MPLS cloud only. And any source machine will never understand what is the MPLS packet. Like any computer uh, never create any MPLS level. If they want to send any packet, then they just encapsulate IP header. They don't know MPLS header. So only these routers uh, will know about MPLS header. So the third work of MPLS is to there are three actually. Push the label, pop the label, and swipe the label. There are three functionality of LDP also. Uh, uh, Not LDP, like these router, the if the MPLS running on each MPLS router, on MPLS running on PE and PE also. So these are called as LSR also. LSR means label switch router. So any label switch router can perform three tasks: pushing the label, pop the label, or swap the label. They might either push the label, pop the label. Pushing means inserting the label, pop means deleting the label, and swapping means to change the label. So actually what happen if we send any in traditional network, if any packet is sent from source to destination, so the destination IP address is the constant. But in case of MPLS cloud, what will happen? uh, the MPLS label gets gets changed. MPLS label is not constant. MPLS label will be uh, MPLS label will be inserted here. MPLS label will be inserted here, and then MPLS label will be swapped here, and then MPLS label will be popped here, because it has because now C router don't know about the MPLS. Now that particular MPLS label needs to be removed. That's why it will use. So you have understood the terminology. This is yeah, and this router is also called ingress LSR, because it is pushing the label. If any LSR is pushing the label, then it will also call ingress LSR, and if any label is popping, then it will call it as egress LSR. Okay, so let's move to the slide. Okay, so we have understood the MPLS. MPLS means multi-protocol label switching is a technique for high-performance telecommunication network. So M MPLS means multi-protocol label switching. So multi-protocol itself means it can support multiple type of protocol. It can support IP protocol, IPX protocol, Apple protocol, or any multicast protocol. So it don't need to care about what type of protocol it is. It can encapsulate any type of protocol. That's why we call it as multi-protocol. And the next one is label switching. Label switching means we are switching the label. Switching means forwarding. So that the router will be used to switch the label. Switch the label. Earlier traditional router used to switch the not used to switch the, they just forward the IP packet, but it is switching the label. That's why it is called label switching. So it is multi-protocol label switching. So it is used in telecommunication network. Okay. So it directs data from one network node to next based on shortest path level rather than long network addresses. So the same thing which I discussed you we used to use long network addresses, but in MPLS we use shortest path levels. So which increases the efficiency of the router, and we have avoided the complex lookup in the routing table. And when the complex level has been avoided, it means the efficiency of the router has been increased. So we have understood how MPLS works, right? So MPLS works by adding a label to each packet, which allow router to make forwarding decision based on the label instead of analyzing the entire header. So MPLS router means LSR, which I told you, label switch router. Label switch router just don't analyze the long IP header packet. They just see the shortest label, and then they add the label, and they take the decision on the basis of label. They don't take the decision on the basis of IP header. So this is a label switching mechanism which we use to improve the network performance, and the complexity has been also reduced. Okay. uh, so like yeah. So every one of you know what is control plane and data plane, all right? Because that also needs to be understood. Like control plane, uh, which means like RIP, OSPF, EIGRP, ISIS, BGP, and LDP. Like the control plane means the CPU has been involved, and once the CPU has been involved, then uh, it will take more CPU utilization, and it doesn't need to care about the data traffic. So control plane means routing table. When routing table gets created, so when the traffic is sent, like hello packet used to send, and the update message used to forward to each neighbor. So these are we call control plane traffic. And what is data plane traffic? Data plane traffic is the like actual forwarding, uh, like a high table and all, something and all. Okay. So what is SDN? Software defined networking is a network architecture that separates the control plane from the data plane. So in traditional router, we used to use all. Let me tell you with one. This is the picture of traditional router. So this is the picture of traditional router. So it has. You can see some line cards over here. Some line cards over here, and you can see its above part. So here some CPU and all. So usually we say the control plane is here and the data plane is here, but you will not see any practical things on command basis. Like there is no any command, such command like so control plane or so data plane. This is just concept. So I need to actually discuss it. So I'm copying it. Yes. So this is the control plane, and this is the data plane. Data plane is gets connected with control plane with the help of switch fabric. Switch fabric is on the back of the router. So the data plane is connected with control plane, and now you can see the data. Each router will have its own control plane and data plane. So the main problem of this is having we will have the network administrator will have distributed control. It will not have uh, centralized control. So but what will happen, but what SDN has does, SDN has decoupled the control plane and data plane. Now you will not be able to see any control plane on the VS router. The control plane has been moved to to the controller. Like in case of SD-WAN, this control plane has been moved to vSmart, and on HD access it is moved to its own controller. So all these, all the VS routers doesn't have. So what we are getting benefit, we are just getting what benefits we are getting to decouple the data plane and control plane is we are now having centralized management. Earlier we used to have um, distributed management. Now we have centralized management, and we have a good control of network resources. Now SDN key concepts. So SDN decouple the network control and forwarding function, enabling programming, network management, and automation. So the same thing. Uh, it has a good kind of network management, and we can, if we want to automate things, like earlier we used to configure each and every router manually. But if we are using SDN, then it is not required. All the things, all the configuration part, it has been automated. So uh, with the help of templates, we can just go to the one controller in SD-WAN. In vManage, we can just create the template and we can push the templates. So that particular one template will get installed on each and every router. The control plane is abstracted and managed by centralized controller, while the data plane consists of forwarding devices such as switches and routers. So the data plane will remain on, will will still exist on the managed routers. And on all the router, we have only decoupled the control plane and we have put it to the any one location, and now we are having centralized control, and now from that particular controller we can manage all and every devices. IDN provides a flexible and agile network infrastructure, making it easier to deploy and manage network services. Yes, correct. So it's a flexible thing. So what benefits we are getting? So simplified network management and configuration through centralized control. So we can manage all the network devices. Earlier it was complex to go to know where is the device, which is the device, where is the problem. Now we have centralized control on one single plane of glass, and from that particular single plane of glass, we can monitor all of the things. Or we can monitor all of the WAN devices. Enhance network agility and scalability, allowing for easier adoption of changing business needs. So business needs are getting changed. So I earlier all business used to have only one network connection, but now business needs are changing. Sometimes they say we want hub and spoke topology, sometimes mesh. So it keeps changing. What is the problem with traditional network? When business demand changes, so it will take months to do that particular change. Suppose any business particular running on hub and spoke topology, and they have come with the concept that now we want to move to mesh topology. So with the traditional MPLS, it will take lot of time to convert this topology. But with the help of SD-WAN, we can do this in fraction of minutes, in 1 minute or 2 minutes. So this is very easy. Cost saving through reduced hardware requirement and operational efficiency. We got operational efficiency. Earlier, we used to deploy site engineers or network engineers to each site, but now it's that much not required. So we can say cost has been reduced. So key points of SD-WAN, we have got centralized control, we have got flexibility, and we have got efficiency. So SD-WAN is a solution. What is SD-WAN? SD-WAN is a solution to provide a replacement for traditional WAN router and are agnostic to WAN transport technologies. Okay. And simplified the management and operation of WAN by decoupling the networking hardware. Like it had decoupling, the same thing which I told you. So what is the difference with traditional WAN versus SD-WAN? So traditional WAN relies on a single private connection for network traffic. Traditional where WAN was dependent on the, like if any site has taken the connection from service provider, might be they have taken MPLS connection from the service provider. So now that particular site is dependent on that service provider. Like routes will also, that side will get the routes from that service provider. So, but in SD-WAN, it is not dependent on the service provider. It depends on the its own. It has own mechanism of OMP, which is overlay management protocol. It gets all the routes uh, from the vSmart. So that's why that dependency has been removed, and we can now utilize multiple connection type. We can use broadband, LTE, and MPLS, and we can also smartly check what is the best route. So we can define policies on the vManage also. So traditional WAN was complex and it was time consuming to configure. So it used to take a lot of time, but with the SD-WAN, we can just do it from templates. So it offers centralized, simplified management and configuration. Traditional WAN also has limited scalability and flexibility. If any company wants to deploy more sites in another location, so it will used to take time, more time, and it was complex. But with the help of SD-WAN, it is very flexible. With the help of GTP, we can configure zero GTP is zero touch provisioning. With the help of zero touch provisioning, we can configure uh, all the routers, all the network devices, all the WAN devices uh, automatically. So why we want to move to SD-WAN? So it will increase the productivity and it will increase the customer experience, reduce inefficiency of higher latency, heavy data center load, and a single point of failure. Yes, earlier we used to have single point of failure, but now we are, if we want to use SD-WAN, then we will get better management. That's why every company is moving towards SD-WAN. Also, we have reduced lost and maximum uptime. SD-WAN ensure that it ensure maximum uptime. So why Viptela SD-WAN? Why we want to we should use Viptela SD-WAN? Because Viptela SD-WAN provides some additional feature like if we want to connect any location, then we can use GTP server. With the help of GTP service, we can automatically configure transfer independent WAN. With the help of Viptela SD-WAN, we get this feature also. End-to-end security also we get. So underlay architecture of Cisco Catalyst SD-WAN. So in underlay architecture, we secure connectivity, multipath routing, and dynamic path control. And on overlay, if we use overlay architecture, then we can use application optimization, automated orchestration, and secure segmentation. So we are having 5 types of SD-WAN control components: the vManage, V1, vSmart, CEdge, and vEdge. So vManage, V1, and vSmart are called as control components, and CEdge and vEdge are called as data components. So I told you that we have decoupled the control plane and data plane. So the control plane, the entire control component has been become vManage, V1, and vSmart, and the data plane has been remain on that particular router, and it is called as CEdge and vEdge. So on vManage we used to manage all the vManage a single plane of glass from where we can uh, configure configure all the things. We can monitor all the things. We can configure it with the help of template, monitor all the things. We can troubleshoot easily. So all site, all health status we can check from one pane of glass. So uh, vBond is also called as orchestration because vBond is used to perform the authorization. That's why whenever any device gets initialized, it first go to the vBond, and then the certificate gets exchanged, and then vBond send the information of vManage and vSmart to that particular site, and then that particular site create its control connection with vSmart. So and once it gets the information uh, of vSmart, so we are OMP pairing gets established, and once OMP pairing has been established, it share its routes. All branch and routers will share its routes to vSmart. So that's the controller. That's the functionality of all these three controllers, and the data plane are VH. Data plane, we are seeing VH and CH. So VH means it's a Viptela edge. CH means Cisco edge. So and on Cisco Cisco router, we might have ISR router, ESI router, white box. These are things. So what is we want? We want is the first point of authentication. I told you, first point of authentication. Whenever any site comes up, it gets connected to at first V1 controller only. Orchestrator connectivity and management, all other component need to know the V1 IP. If you are not using GTP on your GTP on your SD-WAN fabric, then you need to you need to use you need to manually configure some initial configuration. Not much configuration. There are some initial configuration like system IP, like system configuration and VPN configuration. So when you configure initial configuration in these managed routers, then we provide some information like system IP. This it will have this system IP. It will have this organization IP. So along with these detail, we also give the detail of V1 router, the detail of IP address of V1 router at initial point of sale. So whenever at first when they initialize, that's why they can go to the V1 controller first. So vSmart facilitate fabric discovery. Like fabric discovery, it just it just it is just responsible for the control plane. Now from the on vSmart, we can decide what type of routing table we want to use, where we want to use which type of topology. So all the control plane will be responsibility of this Cisco vSmart. So it establishes pairing with all VANage. It establishes OMP pairing, which I told you. OMP is Overlay Management Protocol. Cisco vManage is a single pane of glass for day 0, day 1, and day 2 operation. If you want to do anything, like if you now you don't need to go to any router. Now you don't need to go to even you don't need to go to the any controller only. You don't need to go to any vSmart for filtering. You don't need to go to any vWand, because all these things are already added to the vManage. And now with the help of that vManage, you can access all the SD-WAN fabric. And in all SD-WAN fabric, all components are comes. We add one by one on vManage. So it is a process. So with the help of Cisco vManage, we can upgrade the software also. Earlier, it was very time consuming process. We need to send any site engineer to the site, and that guy will used to manually reboot the router. But with the help of vManage, it is not required. We can just do it with the help of vManage only. We don't need to go anywhere, and uh, it will take only few minutes. And if we want to do any troubleshooting and monitoring, we can do it with the help of vManage. If we want to configure any router, or if we want to change any if we want to change configuration of any router, then we can configure templates. And if we want to change any control plane information, if we want to filter any route, then we can create policies. So like you can see, to create the policy, this is the responsibility of vSmart, but we can do it on the vManage also. We don't need to go to the vSmart also. Later vManage will push that information to vSmart. Cisco CH and VH. So CH and VH are WAN edge router which are connected at the edge of the customer premises. So WAN edge routers actually they establish control plane whenever they get information of vSmart, and they get the WAN edge routers get information of vSmart when they create tunnel with VH. So after successful tunnel creation, vBond will provide the information of vSmart. So then when a router will create uh, secure DTLS tunnel with vSmart, and that will be used for OMP. Implement data plane application aware routing policy. So if any data plane policy we configure on the vManage, then that policy will also get installed on the managed routers. Okay. So these can be physical or virtual router. Also, I told you vManage, vWAN, and vSmart are not physical appliances that were virtual appliances, and VH and CHS can be physical or virtual. So VHCH, what kind of devices we can use? So we can use ISR 1000 router, we can use ISR 4000 router, ASR 1000 router. So these devices we can use. If we are using cloud network, then uh, on Amazon, on AWS, on Azure, we can create that thing also. So and we had this is a Viptela. These are Viptela routers. So these are the serial number. These are series. VH 1000 series, VH 100 series, VH 1000 series, VH 2000 series, and VH 5000 series. So only these types of routers. Not all the routers we can use on VNH, but only these routers we can use in the VH routers. So these things we have discussed. Okay, so SD-WAN underlay network represents the hardware infrastructure, all network devices that connect to the available WAN transport and local site network. Uh, so let me open my virtual machine. Because I have one topology there, I can discuss this thing. So this is the I have installed all controllers like vManage, vWAN, and vSmart, and all VH. So entire SD-WAN fabric I have deployed on my personal computer. So I have installed EVNG, and on I have installed VMware. On VMware I have installed EVNG. So I need to log in. So the default username is root. The password is if it is showing. So once I have logged in, I can go to this particular site 192.168.1.6. Then I will get the access of my Eve lab. Login, sign in. Okay. So this is the topology which I have uh, used in my lab. So I'm telling you about underlay network. So what underlay really refers to? Look, these VH routers are directly connected to MPLS network and internet network as well. So this is actually we call underlay network. This is underlay network, and on this underlay network, when this managed router will create its control connection with these controllers, so that we will call uh, overlay, and this is underlay. And any route we are getting with the help of MPLS, so that will be underlay route, and OMP routes we will get from vSmart, so that will be OMP overlay routes. So this is the same thing which is described over here. So control connection to we want if we switch on any if we switch on power of any VH router, then it goes to the GTP server. If we don't have GTP, then we need to manually configure some initial configuration, like I told you, system configuration and VPN configuration, control connection. So this we have discussed this thing that whenever VH router comes up, then it goes to the V1 router, then DTLS tunnel gets created, and then that V1 router will send the information of vManager and vSmart, the IP address of vManager and vSmart to this VH, and then it will create another tunnel, DTLS tunnel with vSmart and vManage. And once OMP pairing comes up with VH to vSmart, then it will start sharing its mm, its service route information to the controller. So this is the same thing from, yes. What is OMP protocol? So OMP protocol stands for Overlay Management Protocol. So it's a network protocol used in SDN environment. So we are using it in SDN environment. So to control the overlay network. Okay. So OMP protocol never run on underlay. OMP protocol is running over the underlay, means it is running on overlay. Okay. So OMP protocol enable communication between SDN controller and the network devices. With the help of this protocol, uh, network devices can communicate with the SDN with a vSmart, and then it gets the route. Okay. So yes, in OMP also we share some kind of information. OMP share actually three types of route: uh, OMP route, TLOC route, and service route. So OM, so these are service routes. If suppose that if this VH will share this routes to vSmart, so then this is we will call this route as service routes, and then we if it will share the information of TLAC to vSmart router. Information of TLOC means the TLOC and the next hop IP address. If this information, if this information to vSmart, then this will call as TLOC route, and OMP route, TLOC route, um, and service route. These three types of route it usually share. And one more thing, uh, on this VS router there are two TLOC. One is MPLS and one is internet. TLOC is a combination of system IP encapsulation and the color. So system IP might be it has system IP of 1.1.1.1, and the color. So it usually use the concept of color. So we assign this interface as MPLS color and this interface as internet color. So it has two TLOC. One is 1.1.1.1 MPLS IPsec, and another TLOC is 1.1.1.1 Internet IPsec. IPsec is an encapsulation. We can also use GRE, but if we are not using GRE, then by default it use IPsec. So the combination of these three things is TLOC. Yes, this is what I described you. OMP routes, TLOC routes, and service routes. So three types of routes are advertised with OMP. OMP Pro on OMP routes, it advertises the prefixes of the local site, which I told you, the prefixes of 10 network, 10.2.1, 10.2 to the 3.1 network. So it might also learn from any route from the any BGP and all. So TLOC route are the tunnel endpoints. So this is the tunnel endpoint because ultimately tunnel gets created. So it is the tunnel endpoint. This is the tunnel ka endpoint. MPLS tunnel, and this is internet tunnel. Internet TLOC. So the system IP address, link control, and encapsulation type. And service routes are used to exchange. Yes, if we are using any kind of firewall and all, so the information of that particular firewall, so that will be shared by vSmart. The information of firewall, where the firewall is installed. So that particular piece of information we will call as service route. So we have some terminology like system IP organization, which I told you. System IP is a unique identifier in SD-WAN overlay. Like you might remember in OSPF we used to have router ID. So it is same. Router ID is same as system ID in SD-WAN. Okay. And site ID, we assign site ID to each and every site. We assign site ID to this particular site. This is site 1, site 2, site 3. Might be we have assigned site ID also. It is like 1.1.1.1. It might have this kind of and it might have only one dotted notation only. So this is the site ID. What is the use of site ID? Like you can see this site has only one VH router, and this site has only one CS router, and this site has two CS routers. So when these two routers will share its prefixes information with the vSmart, then what will happen? vSmart can easily recognize it comes from which site ID. And when this information will be sent to another VS routers, so then that VS router will create connection, uh, will create IPsec connection with each VS router automatically. So what will happen? Like this site has different, this customer has router has different site ID, and this customer has router has different site ID. So both routers will create IPsec tunnel. Now in this case, what is this customer has router has same site ID, and this customer has router has same site ID. So this router will not create IPsec tunnel. So this is the main main thing of site ID. Another is the organization name. Organization name should be unique, and it needs to be registered on the Cisco vSmart account. And whenever you purchase any device, you need to mention this organization name on every controller, on every site. So this information, system ID, site ID, organization name, needs to be present. Uh, we usually tell routers at the time of initial configuration. So these three comes under system configuration when we configure any site. TLOG, we have discussed system IP color encapsulation. It is a combination of TLOG. TLOG on TLOG addresses. Sorry, on TLOG route. What information we have? We have a TLOG, and apart that TLOG interface. You can see private IP address of the TLOG interface associated. So what will have on TLOG routes? It will have information of TLOG and then information of TLOG route. It means might be 192.168.202.2. We have assigned this IP address to this interface. So then this information will be shared to the vSmart also. So this is the TLOG route. So service routes are uh, these routes are called service route. Actually on VS we have two types of side. Uh, transport side, and service side. So on transport side, MPLS, this router is connected to MPLS and internet. So that's why we call this transport side. And any LAN network is connected to this interface, then we will call it as service side. So this is service side and this is transport side. On transport side, we will configure VPN 0, and on service side, uh, we will configure another VPN. But on transport side, it is fixed number, which is VPN 0. We cannot use any other VPN on transport side. So next, this is we have, yeah, VPN segmentation. Okay, so if we are using VPN 10 here, VPN 10 here, VPN 10 here, so on all service side of all VS routers we are using VPN 10. So by default, all the VS router will be able to communicate with each others. But if we want to segment, if we want to, if we want to differentiate, like if we want that this site needs to be communicate this side, but this site should not communicate than this side, then we can segment VPN also. We can say that this is a VPN 5 and this is a VPN 5. So same VPN they will communicate, but this will be VPN 10. So this will not be able to communicate any of the side. So this is a VPN segmentation count. Sorry, VPN segmentation. Service VPN, I have told you, apart from VPN 0, we can use, yeah, one more management VPN. Transport 0 is VPN 0 is transport VPN, and VPN 512. We also have VPN 512. VPN 512 is used for to manage that router. So apart from VPN 0 and apart from VPN 512, any VPN is specified in the number will be called as service VPN. So VPN 1 is a service VPN, 2 is a service VPN, 3 is a service VPN, any VPN apart from 0 and 512. Bidirectional forwarding detection. So once IPsec tunnel will get created. So IPsec tunnel, you don't need to configure on each routers. It will create IPsec tunnel will get created automatically. Okay. So once this IPsec tunnel is created, so inside that tunnel, BFD is also runs. So BFD ensure you can to check the path liveness and quality measurements. So if you want to continuously monitor the link, then we use BFD. So if you want to deploy SD-WAN, we have two options. We might deploy it on-prem or we can host it on controllers. So if we want to deploy in on-prem, then we can use ESXi or KVM on physical server. I told you like these controllers are not physical appliances. These are virtual appliances. So that VM, the VM will be created on the servers. Okay. So these are VMs. V1 is a VM, vManage, vSmart, vSmart 1. So these are vManage. But if we want to host it on cloud, then we can host it on AWS or Azure also. Even we can also host it in Cisco. But Cisco eventually host it on AWS. So we have three options to host. But what we get benefit to host in the Cisco, we get actually they have some business plans. So on that business on the basis of that business plan, we can get the subscription from the Cisco. So that is called Cisco Cloud as a service, Cisco Controller as a service. Sorry. So now we will see controller scale. So if we have 1000 devices, then we will not have any problem. If we have 1500 device, then we have not problem. But 2000 is a limit. If we have 2000 number of WAN routers, then vManage can handle. But it will uh, if we have lots of site and lots of uh, WAN devices, then we need to increase the uh, deployment. And this is the thing that we can deploy 6 vManage instance in a cluster. So this is the capacity of vSmart. Like it can maintain 5400 connections per single vSmart. Okay. And how maximum vSmart you can deploy? Maximum limit is 20 vSmart, and the maximum limit of vWAN is 6 vWANs. So controller identity is a very important thing. So controller identity is usually verified with the help of certificate. Actually, we have two types of certificate. We have root certificate. We have root certificate and identity certificate. Uh, Let me tell you with the help of uh, I need to Cisco D Cloud. If I log into Cisco D Cloud, then I can access any service of Cisco. I can take the demo at free of cost. So now if I want to take the access of vManage, then I can do this on Cisco D Cloud. So this is completely free. So you need to log in on the Cisco D Cloud account.
In your Shivam, just a small question. In your previous slide, you said there is a limit 20 20 vSmart we can install, we can configure, and per per vSmart it support 500 5400 connections per
Yes.
single vSmart. So this 20 vSmart can configure in single instance, or it's a different
No, this is the overall limit. This is not a single instance. This is,
no, in single
yeah, overall
instance
cluster.
means
Yeah,
okay, okay.
it is the overall limit.
In single environment.
Yeah. So this is a dcloud environment. I'll tell you how we can take access on the dcloud. So it is loading. So you can go to the catalog. If you want any like here you can see, you can also have a guided demo, you can have an instant demo. So currently we are looking for an instant demo, so I click on the instant demo tab, and now I'm looking for a SD-WAN environment. So I'll type over here, I'm looking for SD-WAN here. So from here I can take the access of SD-WAN label lab. It should log in, it should at least show first. Yes, the second lab I'm able to. So default, I think it is have the default username is demo. The password is this is a default demo 1234. I hope it will log in. You can also schedule uh, any session with Cisco if you don't want a quick demo. But we are if we get a session from quick demo, then it's good.
Shivam, Sharanappa here. On the D Cloud at the Cisco, this is free, right?
Yeah, this is absolutely free.
Free, right? Okay.
Yeah.
Okay. Okay. Great.
So see, we can see this is vmanage. So this is how vmanage looks like. So we can see overview. So we can see how many controllers we have. So it has said that we have two V1, we have two vSmart, you have one vmanage. You have one. You have how many vanages you have? So you have 11 vanages. It can show certificate. Yes, I was showing you certificate status. So it is showing certificate status. So when I click here, so I can see it is showing the warning. It is showing warning. The expiration date is showing September 10, 2021. Okay, at first let me tell you what is certificate. Okay, then I will come to you. I was discussing you that we have two types of certificates: root certificates and identity certificate. Okay, so if you are using Cisco environment, then you don't need to install root certificate on vmanage. But if you are using on-prem CA server, then you need to install root certificate on vmanage manually. So how can you see whether this is using Cisco or on-prem or not? So you can go to the administration, and then you can click on the setting. You will get this page, and you will check on this particular controller certificate authorization, how the controller certificate will get authorized. So it is showing it will be Cisco. It means if it is Cisco, then we don't need to install root certificate on this controller on vmanage, because root certificate are by default get installed of Cisco. If you are using Symantec also, then Symantec root certificate are also by default installed. Symantec means DigiCert now. But if you are using enterprise root certificate, then you need to install it. So it is showing you that you have four things. You have four types of signing. How can you sign the certificate? So my certificate will get signed by the Cisco. So Cisco recommend you should use this, but some people, some organization use different for security purpose. So on Cisco, you can see validity period. You can uh, shed 1 year and 2 year validity period. So if you are using enterprise, then you need to click on manual, and then you need to click on um, then you need to install the root certificate, and that root certificate from where you will get from your enterprise certificate authority server. So this is the root certificate, and Cisco, if you have Cisco, then you don't need to install Cisco root certificate, but you need to install now let's come to the second part of the certificate, which is identity certificate. So how you will be able to get that identified certificate? You need to go to the configuration, you need to go to the certificates. Let's understand controller first. So how you will request for identity certificate? So you need to click on the generate as a this is the v1, this is vsmart, this is vsmart, this is vmanage. So identity certificates needs to be installed on all of the controllers and on all vanage list. So on this particular if you want to install identity certificate, then you need to first generate CSR. CSR means Cisco service request. Dcloud don't give us the permission to run this command. So what I'm going to tell you, if you are using Cisco, then you don't need to do much thing here. When you will click here generate CSR, then it will directly go to the Cisco PNP server, and then PNP server will automatically sign that certificate and will automatically push the real certificate to this controller, and then we will do this one by one manually. But if you are using enterprise CS server, then you need to do some work. You need to generate CSR, then you will copy that CSR, then you will go to the CS server. Then CS server will sign, then you will have to manually copy that identity certificate from there, and then you need to click here, and then you will get install button here, then you will have to manually configure here. So these are the two things. So these certificates are used to for authentication, for security purpose. So identity certificate is like we all people have our passports, and also this is our identity, right? So this identity certificate is the identity of this controller. So we identity certificate of V1 is the identity of V1. Identity certificate of vSmart will be identity. Yes, this is the valid vSmart. And who is authorizing it? In case of enterprise, your on-prem CS server is authorizing. In case of Cisco PNP server is authorizing it. In passport also we get the uh, stamp and all this type of value. So once all the routers will have identity certificate, then they will communicate with each other. So suppose v1 2 is communicating with v1 1. So how v1 1 will know that v1 2 certificate is valid or not? So the answer is the root certificate. The v1 1 has root certificate. With the help of root certificate, it will know, yes, this is the valid certificate. So root certificate is same on all the controllers, and identity certificate is different on all the controllers. So this is the controller's identity, and how this happen on
for vantage list. So on vantage list, we use whitelisting. We need to give information of all vantage devices in the Cisco PNP, Cisco PNP server. Then we will give all the vantage list or serial number and all details. Then we download that particular file. Let me tell you here. Actually, what happened right now, I can't show you PNP because it will require Cisco Smart account. So if you have Cisco Smart account, then you need to put the information of all vantage devices on that Cisco Smart account, and then you will download the vantage list there, and then you can upload that vantage list uh, here. Configuration devices. So that vantage list will gets uploaded in the vmanage, and then vmanage send then that vantage list to the vbond, and then vbond will have the detail of all vantage devices. So this is whitelisting. Uh, so it will provide security. Not any other vantage router will dare to come. Not any unauthorized router will dare to come in SD-WAN fabric, because it will be automatically rejected by the V1 when it will communicate with our V1 router. Okay, so this is the vantage deployment option. We have this. We have three types of options. We can either go for automated provisioning, or we can either go for manual provisioning. If we are using if we want to use automatic, if we don't want to provision anything, then we can use GTP. One more thing, GTP is will be only used if you have Viptela as devices. Like the configuration of Viptela as devices will be done by GTP, and the configuration of iOS devices will be done by PNP server. So this is the main difference. You have uh, if you are using two types of devices in your ID1 fabric, then you need these two types of uh, servers in your. Yes, if you want to use manual configuration, then you can use YCL, which I told you, like system configuration you need to configure. Then you need to configure VPN configuration, VPN 0, VPN 5.2, and VPN and the service VPN. So this is this will tell you how the automatic process will works. Um, this is how the manual deployment work when a device is basically configured via the console port. So initially, if you are using manual deployments, then at initial level you need to use the console port. But on initial level, you need to do some minimum configuration. On system configuration, you need to uh, tell the router that what is your system IP, site ID. You need to configure this thing, organization name, and V1 IP address. So V1 IP address is very useful, important here to give that particular router, and then VPN 0 interface. Yes, you need to configure VPN 0 interface. VPN 0 interface is the transport interface. So when an authorization, yeah, it will do with the help of root certificate, device certificate. Device certificate is identity certificate, which I tell you, which I told you. So what are the benefits of Cisco Catalyst when we have enhanced agility, cost saving, and improved security? So with the help of certificates, we can improve the security, and um, like all of you know, business demands always gets changed day by day. Topology there changes. So with the help of traditional MPLS, we can't achieve this thing very quickly, but with the help of SD-WAN, we can achieve this. So these are the benefits of Cisco Catalyst SD-WAN. So conclusion is that we have got ease of management, enhanced performance, and cost efficiency. So ease of management, like you can configure. You can monitor all the thing with single pane of glass. Bhumanage is the one pane of glass which you have to look. Don't need to go anywhere else. So this is the conclusion. We got these 3 points, which is very good. So thank you everyone. This is all from my side. I hope all of you have enjoyed it. So if you have any question, you can ask. So no question.
Yeah,
No,
Shivam,
Shivam.
thanks for the session. It's a wonderful and a good session. Can we get the recorded this session?
Aftab, have you recorded the session?
Yes, I believe the recording is
Yeah, it's recording.
Okay.
going on.
Yeah, it's
and-
recording.
Fine.
Yeah.
Fine.
So that will be uploaded in the chat. Yeah.
Yeah, fine. Shivam, thanks once again. In general, one small question. If any vulnerability on this platform, so can we identify if any attackers or something? In general, I'm asking. So can we get any
Yeah, yeah.
pop-up?
Yeah, actually, on the VMNet dashboard, actually, it don't get. So this is the Cisco product, right? So let me share my screen. You need to go to the Cisco Software Central. Then downloads. So I don't think, let me but try. Yes. See, so here we have SD-WAN right now, whether I have logged in or here. No, I have not logged in. So once you will log in here, this is the Cisco site from where you can download these vManage software, vSmart software, and VH Cloud. So once you log in, you will get a notification point over here, notification button here. So you need to click on that button. So whenever any Cisco discover any kind of vulnerability in their solution, in the vManage, in the vSmart, any controller or any VH, so they will just send you the alert over the mail.
Okay. Right.
Yeah. So you will
Okay.
get the, once you log in, you will get this thing.
That is Cisco Software Central, right?
Yeah.
Okay. Okay. Thank you. Thank you, sir.
Yeah.
So Shranappa, here you can check on the Cisco portal, but generally Cisco vendor is sending the notifications to the customers that they discovered the vulnerability in that product and required update.
Okay.
So you can plan for the update.
Okay. 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 Thank you. Thank you.
So
Yeah.
if you are using, if you have Cisco vSmart account, then you don't need to go here also. You need to go to the if you have Cisco vSmart account, you will update that information in the Cisco administration setting. Then you will get automatically updates over your mail.
Okay. Okay.
Yeah,
Yeah.
means Cisco already means proactively monitoring the all vulnerability in their
Yes.
products in advance.
Yes. Hmm.
So they will intimate you what version you are using. It's a vulnerable or it's a safe from it. So in
Yes.
advance they will inform you. So accordingly you can act on that.
Yes. Yes. Correct. Actually, last 2-3 days back, some of the on the voice video product, there are vulnerability around 8.6, 9.6 something on the two different products. So that's the
Mhm.
reason. So I just asked. Thanks for the input and the information. Thank you.
Okay.
Yeah, sure. Welcome. Any other?
No, Shivam, I think you have cleared everything.
Okay, so that's it for today. Thank you very much for joining the session. So if you further have any doubts, you can reach me you can ping me over the Teams. So thank you everyone. Yeah.
Yeah,
Thank
thank
you,
you,
Shivam.